up here. I just sucked over this equation, 0.02861 blah, 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 plus 71.83 blah, blah, blah. I sucked over that whole equation and didn't have to type it in. That's what I just did. I sucked over the y equals all the yellow times x plus all the blue. Now, I have mine so that it's on 3 different lines. Yours is probably on 1 line, and you just got to scroll over to see everything. So what we just did is we copied that entire equation into the y equals. So now we're going to do zoo 9. What does zoo 9 mean? Look at me, girl. Look at me. I've done all this work. I better strut it. So now we're going to go out there and we're going to do zoo 9. Look at me. So it took all my points from L1 and L2, and it took my line that was all up into Kool-Aid from y equals, and it put them all on the same graph. So it is pulling from 2 different spots. It is pulling my real life data so all of my real life data is all of this. And my equation that it's predicting is there. So it's pulling from 2 different places. So now I'm ready to make a prediction. So where do I go? And I have it right here just in case we need to cheat. Where do I go to make a prediction? We go to that table. Remember back in Algebra 1 when y'all did that little table? And if I go real simple, if I go x plus y equals 5, if x is 3, what is y going to be? 2. And if y is 1, what is x going to be? 4. Remember doing that back in Algebra 1? Well, y'all, this problem isn't that easy. It's not that easy. We wish it was, but it's not that easy. So we're going to let the calculator do this for us. So we go to second table, so second graph, second table, and we plug in the values that it wants us to use. So for this problem, it wants our brain size to be 950. Well, at the beginning of the problem, we let our brain size be the L1. And our L1 is the same thing as X. Our L2 is the same thing as Y. So our brain size is our LY. Our L1 or our X. Our IQ is our L2 or our Y. So they're saying they want 950 to be our brain size. So now all we're going to do is go to our calculator and we're going to plug 950 in for the X, which is really the L1, which is really the brain size, to figure out what is the Y, or the L2, or the IQ. And the other thing is the 1300. The 1300 is your brain size. There's going to be your IQ. Now, so this was the L1, this was the L2. This was the brain size. This was the IQ. So those are your answers for Part D. Now, on your test, you're only going to have one of these because this took a while. This took a long time. Now, on your answer sheet, I didn't give you the scatter plot, but I did give you the equation. I did give you the R value, and I told you that it was weak positive, and I did give you if your brain size is 950, your IQ is 99. If your brain size is 1300, your IQ is this. Now, if I scroll all the way back to the top, there were a couple of questions there. Is there sufficient evidence, is there enough evidence to conclude that there is a linear line correlation between brain size and IQ? Is there a line?
Weak line.
It's a weak line. Does it appear that people with larger brains are more intelligent?
A little bit.
Okay, so if I come down here, this person has a smaller brain, so they have a lower IQ. This person has a larger brain, so they have a larger IQ. So we learned in 7.1, or at the beginning of this chapter, that if the correlations go in the same direction, what kind of correlation is that? Positive correlation. Now, if I had to bet money on this equation, would you bet money on this? Why would I not bet money on this? Because it's very weak. It's not a good predictor. It's not very linear. Now, if I graphed my points and my points look like this, I'd bet money all day long. It's a very good predictor. This one is not a good predictor. I mean, even though we plug numbers in there. So y'all, if you have a big head, should you expect to be more intelligent?
No.
No, because this is a weak correlation. Y'all with me? Are we feeling better about these? All right, let's go on and look at some more. Beware of outliers. What does an outlier mean? We talked about this in the last chapter. They don't belong there. If everybody makes good on the test and there's that one person that makes really low, or if everybody fails a test, there's that one person that makes really high. And we did the basketball players. Everybody made nothing when they graduated college and they were basketball stars, except that one person that made $7 million or whatever. So in this problem, do we see an outlier? Heck yeah, right there. So if I ask you to give me the ordered pair of the outlier. Now, when I used to teach math back in the day, and I used to teach about ordered pairs, I would say swing to the left, swing to the right, stand up, sit down, fight, fight, fight. So when you do an ordered pair, your first is on the x-axis, your second is on the y-axis. So when I'm doing an ordered pair, I always start at the origin, and I always swing to the left, swing to the right. So where would I be swinging on my x? 0.5. And then where would I go to my y? 1. So my ordered pair for that outlier is going to be 0.5, comma 1. That is the ordered pair for the outlier. We have visitors. Look, and you're on camera. Wave to the camera. It's in my room, sitting on my desk. Okay. You're taking inventory to make sure we don't steal something. No thieves on campus. It's sitting on my desk. You can, you're welcome. All right, so there's my outlier, 0.51, so make sure you know what that outlier is. Now, down here, they're saying if you were to do a correlation coefficient or an R value with the outlier versus without the outlier. If I took the outlier out, can you see that my R value is really good? That's like an R value of, let's say, 0.98. If I leave the R value in, it's going to be a lot lower. It may be like an R value of 0.68. So that one person's grade is going to drop the average of the class. So sometimes, y'all, when I say, like if I came in today, which I did, and I said the average of the class was an 80.9 on the last test. Well, there was one person that didn't take the test that's not come to class anymore. So I didn't leave that 0 in, because that would have dropped the class's average, but it's not representative of y'all, because that outlier is a 0 and it brought the grades down, but it wasn't representative. So I took the 0 out before I told you the grade, but then I put the 0 back in because that person needed a 0. Y'all with me? So an outlier can affect the data. All right, be aware of inappropriate grouping. We talked about how to survey, how to pick the groups, and how to pick the groups appropriately. They're systematic. We talked about all the different types, cluster, stratified. We talked about all the different types. Random, there you go. Which one am I missing? Cluster, stratified, random, systematic.
What was the other?
Stratified, did I do that one?
Yeah.
What am I missing, y'all?
Is it sample?
No, random sampling, it'll come to me in a minute, there's 5 of them. Alright, so for this one, it says that we pick the data correctly. We picked the good sampling, and this is what we were asking. We looked at high school students, and we said, cluster. It was gonna drive us crazy. How many hours of TV do we watch a week if we're a high school student, and what is our GPA? Is there a relationship, is there a correlation between watching TV and your GPA? Okay? Ashley and Susan say yes. Krisha says no. So we ask people 2 hours a week, this is their GPA. 6 hours a week, this is their GPA. 20 hours a week, this is their GPA. So we put this in as L1 and L2. What causes what to happen? Do hours cause GPA or does GPA cause hours? Hours cause GPA. So this is going to be my L1, this is going to be my L2, and we graphed it. So when we put it in our graph, and we said this is our L1, and this is our L2, because hours, we want to know, does that cause the GPA? And our L1 always causes our L2 to happen. So we graphed it where this is our L1 and this is our L2, and this is what came out. Do y'all see a positive correlation, a negative correlation, or no correlation?
Negative.
Is it going uphill, downhill, or all over the place?
Positive and a negative.
Okay? She says she sees a positive and a negative. She says she sees all over the place.
Probably straight, like the middle lines.
Okay, Ashley says she sees a straight in the middle. Well, if you're a true statistician, you're going to analyze this data and you're going to say, okay, maybe I didn't ask the question correctly. Maybe it looks like a cluster mess right now. I just got a bunch of dots and I don't really see a pattern. So what they did is they went back and said, maybe I just didn't say how many hours of TV you watch. Maybe I should have asked a better question. Not only how many hours do you watch, but what kind of TV you watch. Are you watching National Geographic and the Biography Channel? Are you watching MTV and The Bachelor and that kind of thing? So then they asked those same students, what type of TV are you watching? So this set is watching educational TV. This set is watching regular TV. You know, Survivor, whatever. So if you look at it now, look at the data. So if I come over, that is going to be, and Susan kind of saw it right there. And then here's the other set of data, which is right here. So this was our oops, get my pen back. This is my regular TV, and this is my educational TV. So tell me about the slope of an educational TV.
The more educational TV you watch,
So what kind of slope is it first?
the more positive.
It's a positive slope, which means they go in the same direction, which is up and up. So tell me what you're analyzing. What were you just saying, Ashley?
The more you watch educational TV, the more smarter you are.
The more smarter you are. Yes. The more educational TV you watch, the higher your GPA, because it's positive. Now, with the regular TV, that's a negative correlation. It's going downhill. So, as one goes up, the other goes down. So that means the more regular TV you watch, the lower your GPA. Make sense? And y'all said you would never use this crap. Alright. Let's look at, this one's good. The correlation, we're talking about correlation means a relationship. So there's a couple of things that say the relationship may be a coincidence. You know, you may have met this guy by coincidence. The correlation may be directly influenced by some common underlying cause. Remember, I said crime rate and ice cream sales?
Yep.
If you sell ice cream, there's going to be a higher crime rate. Well, the ice cream had nothing to do with the crime rate. Ice cream meant it was hotter outside, which means kids are probably out of school, which means they're up to no good, which means they're creeping, which means stuff's going to get stolen. So they had nothing to do with each other. It's all this stuff in the middle. One of the correlated variables may actually be the cause of the other. Me eating more is the cause of me gaining weight. So this caused this to happen. So these are some different reasons for a correlation. It may happen by accident or by coincidence. There may be some things in between that cause it or happen, or this may have directly caused this to happen. Hey, if you study for a math test, that may cause you to have a good grade. Who would have thought? So, we're going to do some problems. And I'm going to give you a situation, and you're going to tell me, state the correlation clearly, and then state, is it a coincidence? Is there an underlying cause, or is there a direct cause? Let me cover up. So first I want to know, is it a positive correlation, a negative correlation, or no correlation? And then I want to know, does it happen by coincidence, underlying cause, or direct cause? It has been found that as gas prices increase, the distance they drive gets shorter. So we're talking about gas and distance. So as gas prices increase, the distance they drive gets shorter. So what kind of correlation is it? Positive or negative?
Negative.
Raise your hand if you think it's negative. Raise your hand if you think it's positive. Raise your hand if you don't know. Raise your hand if you don't care. It is negative. Gas prices are going up, so the distances are going down. When they jack the prices up, we're not going to go to the beach for the day. We're going to stay home because it costs too much. So because those are going in different orders, it's going to be a negative correlation. That's the first part of the answer. The second part of the answer was this a coincidence that we stayed home? No. Was there an underlying cause?
No. That was a direct relation.
Because the gas cost too much, my butt stayed home. This was a direct cause. It directly hit my wallet. Directly. I ain't paying money for gas to go for a day because it costs too much. Y'all with me? In one state, the number of unregistered handguns steadily increased over the past several years, and the crime rate increased as well. So first I need to know, is it positive, negative, or no correlation? So, guns, riding dirty guns. Riding dirty guns went up. Crime went up. So what kind of correlation is that?
Positive.
That's a positive correlation. Now, was that a coincidence that riding dirty guns went up and crime went up? Just so happened. Was it a direct cause that just because you buy a dirty gun, you're going to go out and commit murder? So is there some underlying causes? I would say that there is underlying causes, because just because you go and buy a dirty gun does not mean you're going to kill somebody. But most people who buy guns illegally are probably buying them illegally for a reason. Okay? They should make them illegal. There you go. Now, this one, I kind of have some issues with this one, and I put it out here because I don't believe in how they said to do this one, but we're going to talk about it. It has been found as the number of traffic lights increase, the number of car crashes also increase. So tell me, what do you think the correlation is going to be?
Positive.
Positive correlation. Lights are going up, crashes are also going up, so that's going to be a positive correlation.
Wouldn't you think that stoplights would stop right?
See, that's what I thought. When I read this, I'm like, if you put up a stoplight, shouldn't there be less car crashes?
Instead of just a stop sign.
Right. Yeah. This one I didn't like because I'm like, they put a stoplight up there for a reason, but their theory was because there's more cars through there, there's gonna be more crashes because there's more traffic. So there's a more likelihood of a crash. I'm totally with you, actually. All right, is there a coincidence that there's more car crashes?
Oh,
Maybe.
It's just a red line.
That never had a red light, obviously it got a red light. Nobody ain't used to that red light. We going straight through that.
That's why they put all those blinking lights to let you know, hey, coming up is a red light that's never been there.
See, when Dylan, we don't got blinker lights, we just got a red light.
Well, and Dylan's a whole different story, girl.
We went straight through.
Dylan is a whole different story. So, with this one, I would never put it on a test because there's too many variables. Okay, so, coincidence, maybe. What about underlying causes?
Yeah.
I would kind of fight like what Ariel said, you know, there was never a red light there, so there's going to be some underlying causes because people aren't used to it being there. So they're going to have some issues of, oh my gosh, I'm not used to this, I'm going to roll right on through. Okay? Some direct causes, well, they probably put the light there because there were crashes already happening and we're going to put them to try to prevent them, but there's still going to be crashes. So for this one, I probably would take every answer as long as you could provide the documentation. Statistics students find that they spend more time studying if they spend more time studying, their tests are higher. What kind of correlation? Study and grades. The more you study, the higher your grades. That's going to be a positive correlation. Even though I have some people say, I study all my butt off and I still make a low grade. Okay, you're probably an outlier. Just saying. Gotta use that vocabulary. Coincidence, underlying, or direct cause? I would say direct cause. It's directly linked. We've already talked about this one. Ice cream sales and crime rate. As ice cream sales go up, crime rate also goes up. That is a positive correlation. What is the cause? Coincidence, underlying, or this one is underlying because we said that when ice cream sales go up, that means it's getting hotter, which means school's out, which means people are creeping, which means stuff is going to get stolen, which means crime rate's going up. So it had nothing to do with the ice cream sales. Taller people in stats class have better grades. What kind of correlation? There is no correlation in that bad boy. And us short people better be grateful.
So what if we would have got like the ice cream crime rate and we just said no correlation because it wouldn't have like clicked about the
Then I would go back and look at it. Yep. All right, let's talk now. This is the last section, y'all, in 7.3. Yes, boo-boo.
Oh, this might be out of topic, this is going on with the ice cream thing, so basically you're saying that people steal the ice cream truck?
No.
Oh.
All right, line of best fit. Remember, line of best fit is that line that's all up in the Kool-Aid. So if we have all this real-life data, my line of best fit is the line that's all up in the points. That's my y equals ax plus b. That's my line of regression. We've already talked about this. This is just kind of going over it in depth. It may or may not give a good prediction according to what your R value is. And this kind of goes through stuff that we've already talked about. It's just wordy, and I'm wordy, and so, this is not on the test, but it's some good things for us to go over to make sure that we understand it. So I'm gonna put not on test. I don't give you vocabulary per se on test, but you have to know what you're doing. Okay, correlation we've talked about is a relationship. Regression is the process to find the equation that relates the two quantities. So if, like I said, if we have those lines, regression, what we're doing is linear regression. Think about what that means. Linear means what? Line. Regression is the process to find the line that represents those points. And correlation coefficient, we've also talked about as the R. It has no value, no measurement, and it describes the strength. You know, the strength between you and your partner. Is it strong? Is it weak? Is it moderate? Is it a positive relationship? Is it a negative relationship? All right, so let me see if I can make these bigger. Let me hide my answers. Give me just a second. All right, I'm going to let you read the first one. Some of these are going to be easier, and some of these are going to be harder. Hold on. Okay. A unitless measure that describes the strength of the linear relationship between two variables is called the linear correlation coefficient. What did we say describes the strength? Describes how strong the relationship is. The correlation coefficient, the R. The process of determining the linear relationship between two variables is called linear regression. The value of R, which is the linear correlation coefficient, that represents the strongest positive correlation. What is the strongest R value that you can have? 1. The R value that represents the strongest negative correlation. Negative 1. The value of R that represents no correlation. 0. If one quantity increases as the other quantity decreases, it has a negative correlation. Don't make this harder than it is. It's a word problem, I know, and y'all are freaking out. If one quantity increases as the other quantity increases,
Positive.
hey, what the heck? Y'all know it. A plot of data points is called a scatter diagram. The line such that the sum, hold on, I gotta move it up so y'all can see it. The line such that the sum of the squares of the vertical distances between the data points and the scatter diagram and the line is a minimum is called the line of best fit. Ha! Y'all with me?
Yes.
All right. Now, we just talked about the R value, correct?
Yes.
Now, if I gave you these and I said, estimate the R value. Estimate the R value. For number 11, tell me what you would think the R value would be. I would say the R would be about a 0. For number 12, let's start off by talking about, is it positive or negative? It's negative. I don't know why I wrote equals. The R value is negative because it's going downhill. Okay? Is it weak, moderate, or strong?
Strong. Moderate.
Moderate, because it's kind of linear but not real linear. So if it's in the moderate, it's around how many cents? 50-ish. Okay, so we can say 48, we can say 56, we can say, y'all with me? So anything in, I mean, if you give me, oh, my pen just went crazy. Oh my gosh. So if you say negative 58, if you say, I'm not saying anything else, but if you say anything around negative 50-ish, you're fine. It'll be multiple choice. All right, what about the next one? Is it positive or